Welcome back to another video. In this video, we are going to be talking about the graph of the tangent and the cotangent function. So we're going to look at the basic graph, and then in another video, we'll talk more about graph and the tangent and cotangent when it has a change of period and change of and translations such as moving it left and right and up or down. But in this video, we're just going to talk about the basic tangent and cotangent function. So let's jump right in. All right, so here I have the unit circle. And again, we need the unit circle because this is where we pull our function values from. So remember, cosine is x, sine is y, and then tangent is y over x because it's sine over cosine, okay? So we're going to be using the y and the x value to calculate the tangent of a function. And we're going to start with the quadrantal angles because those are typically our points that we use. We're going to start with those and see what we get. So our quadrantal angles are 0, pi over 2, pi, 3 pi over 2, and then back here at 2 pi. So note those points. We have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And let's see what we get for the tangent of each of those. So starting off, we're going to be graphing the tangent of x. So y equal tangent x. And that is tangent. Let me fix that. Again, my screen has been acting up, so just make the best of what we can. All right, tangent of x. All right. And so at 0, the tangent of 0, at the point 0, we have the point 1, 0 at 0, right? And our cosine is 1, our sine is 0. So if we did sine over cosine, the tangent of 0 will be equal to 0 over 1, which is equal to 0. At pi over 2, our value is 0, 1. And so the tangent of pi over 2 would be equal to 1 over 0, which is undefined. So this is undefined. At pi, our point is negative 1, 0. So we would do 0 over negative 1, which is equal to 0. At 3 pi over 2, our point is 0, negative 1. So it would be negative 1 over 0, which is also undefined. And then at 2 pi, we're back at 0 because 2 pi and 0 are coterminal angles. They share the same x and y values, okay? And so that just lets us know that at 0, we're at the point 0. At pi over 2, we have what's called an asymptote because it's undefined. Anytime you have an undefined value, there's an asymptote there. At pi, we're at 0. At negative 3 pi over 2, we also have an asymptote, okay? Now, if you notice, we have asymptotes at every odd multiple of pi over 2. So at pi over 2, 3 pi over 2, that means our next asymptote would be at 5 pi over 2. And if we went backwards, we'll also have an asymptote here at negative pi over 2. And so this doesn't really give us much information to graph, to have an accurate, complete graph. So we need to pick some additional points to plug in to see what is happening in between those asymptotes. So I'm just going to start with this window right here between these two asymptotes. I'm going to pick 2 more points in there. I'm going to pick this point that's halfway between 0 and negative pi over 2, which would be negative pi over 4. And then the same thing here. If I pick the point that's halfway between 0 and pi over 2, that'll be pi over 4. And so I want to figure out what is the tangent of pi over 4. So if I just make some extra points, what is the tangent of pi over 4 and negative pi over 4? So we have negative pi over 4 there and pi over 4 here. Well, remember at pi over 4, if I go back to my unit circle, pi over 4 here, your x and y values are the same. So if I do y divided by x, I'll have the same value on top of the same value, which comes out to be 1. And negative pi over 4 would be here because we'll go pi over 4 in the negative direction. And we have the same values also, except 1 is negative. So that means when I take this y and divide it by this x, because they're the same, but 1 is negative and 1 is positive, that will give us a negative 1. So the tangent of negative pi over 4 will be negative 1, and the tangent of pi over 4 will be 1. So that lets me know at pi over 4, we have the point 1, And at negative pi over 4, we have the point -1. And so what ends up happening in between these two asymptotes is we have a curve. And so asymptotes act like magnets. They pull the graph really close to them, but it never connects and attaches, so it don't touch, but it gets really, really close to that asymptote. So we end up having a graph that does something like this. It curves in that window. And it repeats the same thing. So if you pick the point here, halfway between here and halfway between there, there'll also be a -1 and 1, because a tangent function is also a periodic function, which means it does the same thing over and over again. Okay? And so this is my sketch of the tangent function. It will continue to do that same pattern. Okay? And so here are a few things that we notice by looking at the tangent function. So here's a more formal graph of it, not my raggedy sketch, but here is the graph. You can see I have these dotted lines at negative pi over 2 and pi over 2. That is the asymptotes, and then you can see it curving in between. And then here, where it's -1 and 1, those are the pi over 4 values and negative pi over 4 values, okay? So first thing we notice is that the domain it's not all real numbers because we have those asymptotes, but it is every x cannot be an odd multiple of pi over 2. So that's where those asymptotes take place. So the domain is all real numbers x except for those odd multiples of pi over 2, because that's where your asymptotes happen. All right. Now your range is still all real numbers because the graph continues to go down and it goes all the way up. So all of your y values are covered. Now this one, so remember sine and cosine had a period of pi, but tangent has sine and cosine had a period of 2 pi, but tangent actually has a period of pi. So if you was to measure from negative pi over 2 to pi over 2, this is where that one window of rotation happens. That's a distance of pi. And then it starts to repeat itself again for the next distance of pi. So the period is pi. So the next one is the graph is discontinuous again. That's where your asymptotes are at the odd multiples of pi over 2, which we talked about with the domain as well. But then there is no amplitude. Amplitude, remember, was how halfway between the maximum and the minimum. Well, since there is no maximum and no minimum here, or half of the distance between the maximum and the minimum, there is no max and min here because the graph continues to go up and it continues to go down. And so therefore there is no amplitude. And this is an odd function. It's symmetric about the origin, which means when you take the tangent of a negative angle, it's equal to negative of tangent of that angle positive, okay? And so these are a few things that we notice about the tangent function, and this is the graph of the tangent function. If you have any questions about it, please put them in the comments below, all right? Let's keep going. Now we want to graph the cotangent function, all right? So this is for the graph of, let me scratch that, y equal cotangent of x. All right, so now remember, cotangent is the opposite or reciprocal of tangent. So tangent was y over x, cotangent is going to be x over y. So now if you think about the point at 0, you have the point 1, 0. That's a 1, my bad. So then it'll be 1 over 0, which is undefined. At pi over 2, you have the point 0, 1. And so that would be 0 over 1, which is 0. At pi, you have the point -1, 0. So that'll be -1. Sorry, I'm getting these backwards. -1 over 0, which is undefined because it's x over y. At 3 pi over 2, you have the point 0, -1. And so that'll be 0 over -1, which is 0. You can probably see the pattern. And 2 pi is going to be the same as 0 because they're coterminal angles. That's going to be 1 over 0, which is undefined. And so if we were to graph these, at 0, it's undefined. That means we would have that dashed line going down the y-axis. At pi over 2 is 0, so we will have a point there. At pi, it's undefined, so we will have an asymptote. 3 pi over 2 is 0, so we will have a point there. And 2 pi is another asymptote. So now this time you have asymptotes at 0 and pi. So you have asymptotes at every integer of pi. So 1 pi, 2 pi, 3 pi, -1 pi, -2 pi. So if we were to go backwards, we would have another asymptote here, if you see the pattern. So now we need to know what's going on in between 0 and pi, in between that window. So again, I'm going to pick a value here between 0 and pi over 2, which would be pi over 4. That is what will be halfway. And then halfway between pi over 2 and pi would be 3 pi over 4. And so I need to plug those in and see what's happening at pi over 4. Oops, that's supposed to be x and y. So I need to figure out what's happening at pi over 4 and 3 pi over 4. So at pi over 4, remember your values are square root of 2 and square root of 2. And it's x over y. And because those are the same, when you divide them, the cotangent of pi over 4 will be 1. At 3 pi over 4, your values are negative square root of 2 over 2 and square root of 2 over 2. If you do x divided by y, that will give you a -1. So at pi over 4, you're at 1. At 3 pi over 4, you're at -1. And so now your graph does something like this. And it's another periodic function, and it's going to do the same exact thing in that next window. So actually in all of those windows, it looks like that. It's a curve. And so here is a more formal graph of it. Not my raggedy sketch over here, but I wanted to walk you through the sketching part so you know what's going on. But here's the formal graph of it. You see you have, these are supposed to be asymptotes, but they're just shown as lines on here. But they're actually asymptotes, okay? But you have the curve going down and it continues that pattern. And so what we notice is that first of all, your domain is all real numbers except for the integer multiples of pi. And that is 1 pi, 2 pi, 0 pi, 3 pi. So you can't have a value there for x. Your range is all real numbers because these are essentially arrows on the end of these. They keep going. So these should all have arrows on the end. Also, the period is pi, because the distance from here to here is pi. So the distance between these asymptotes is pi. Again, this is just to let you know where the asymptotes happen at every integer multiple of pi. There is no amplitude also because the amplitude, there is no max and min value. Also, the x-intercepts happen where, we didn't talk about this in the last one, but the x-intercepts happen at every odd multiple of pi. Then I already talked about that. Now this one is also an odd function, which means when you take the cotangent of a negative angle, it's equal to the negative of the cotangent of that angle. And so this is your cotangent function. If you have any questions about the cotangent function, please put them in the comments below. But this is the cotangent, and then the other one we had, I won't go back because I have to do all that, but the other one was the tangent function, okay? So you need to know what the graphs of these look like, and you can also graph these on the graphing calculator in Desmos as well, alrighty? I won't walk you through that because y'all know how to do it. You should at least know how to do it by now. If you have any questions whatsoever, please don't hesitate to put them in the comments below. And if this video helped, if it made sense, give me a thumbs up or a like, and I will see you all in the next video. Thank you.